Hi everyone, welcome to lecture 25 on basic inorganic chemistry. My name is Dr. Teresa Chimambam. For today's lecture, we will study how to calculate grams of acid or base to be used to make a solution at a specific pH. We will also study pH calculations, how to calculate hydronium ion concentration, how to calculate hydroxide ion concentration, and how to calculate pOH. Let's look at this example. What is the pH of a 200 ml solution containing 0.038 gram of HCl? To answer this question, the first thing we need to do is to calculate the number of moles of HCl present in the sample. And to do this, we use the formula for moles, which is equal to mass divided by molecular weight. So we put in the value for mass that we are given, which is 0.038 gram. We put it for mass, divided by the molecular weight for HCl, which is 36.5 gram per mole. So this gram will cancel this gram. If we divide 0.038 by 36.5, we will get 0.0001 mole. Now that we have the number of moles, we can now calculate molarity. Molarity is equal to moles divided by volume, and that volume must be in liters. So we put in the moles that we calculated here, which is 0.0001 mole. We put it for moles. And the volume we are given is 200 ml. We convert it to liters by dividing this 200 by 1,000. If we do that, we will get 0.2 liters. So when we divide 0.0001 mole by 0.2, we will get 0.0005 mole of hydronium ion. So now that we have the molarity of the hydronium ion, which we calculated to be 0.0005 moles, we can now calculate the pH. Remember, you cannot calculate pH if you do not know the hydronium ion concentration. But now that we have calculated it, we can now calculate pH using this formula. So we simply put in the formula down first, and then we put in the value that we have calculated for hydronium ion concentration, which is 0.0005 mole. So if we find the negative logarithm of 0.0005 mole, it will give us 3.30. So this is our final answer. How many grams of KOH are needed to prepare 400 ml of 0.102 mole KOH? To solve this problem, we start by writing the concentration formula, which is equal to moles of solute divided by volume of solution. If we do cross multiplication here, we will get that moles of solute is equal to volume multiplied by concentration. We obtain this formula by simply doing cross multiplication here. So we then put in the values that we are given in this question, in this formula. Concentration is 0.102 mole. We put it here. I have written the unit in this way so that units can cancel out, and we multiply by volume. We are given 400 ml. We convert it to liters by dividing by 1,000. We will get 0.4 liters. So this liter cancels this liter. Our final answer will be 0.048 moles. So then the mass of KOH is equal to moles that we calculated here multiplied by molecular mass for KOH. The molecular mass for KOH is 56 grams per mole. So we multiply this mole by 56 grams per mole. Again, I've written the unit in this way so that units can cancel out. In this way, this mole cancels this mole. If you multiply 0.0408 by 56 gram, you will get 2.28 grams. So this is your final answer. So these are some practice examples that you can practice on your own just to familiarize yourself on how to do this type of calculation. Okay, if you are asked to calculate the pH of an aqueous solution, you use the formula pH equal to minus log hydronium ion concentration. So for you to calculate pH, you must know the hydronium ion concentration. So you need to know this value, the hydronium ion concentration in moles per liter, for you to be able to calculate pH. And we know already that pH is a measure of the acidity or alkalinity of a solution. The pH scale usually ranges from 0 to 14. Numbers below 7 are acidic. Numbers above 7 to 14 are basic, and 7 is neutral. So this is the formula that we use to calculate pH of an aqueous solution. For you to be able to calculate pH, you must know the concentration of the hydronium ion in moles per liter. So let's have a look at some examples. If you're asked to calculate the pH of a 0.042 mole HCl solution, we know already that HCl is a strong acid. Because it's a strong acid, it will ionize completely in water. So when it ionizes in water, it will form hydronium ion plus Cl minus. So to calculate the pH, we use the formula pH equals to minus log hydronium ion concentration. And we are given that this hydronium ion concentration is 0.042 moles. So if we put it in the formula, if we find the negative log of 0.042, we'll get 1.38. So it is a simple calculation. You just need to know the hydronium ion concentration and you put the value in the formula. Now we learn how to calculate hydronium ion concentration when we are given the pH. Okay, the hydronium ion concentration can be calculated using the pH formula by simply making the hydronium ion concentration the subject of this formula. So if we do that, we will get that hydronium ion concentration is equal to 10 to the power minus pH. So it simply means that for you to calculate hydronium ion concentration, you must know the pH. And it is important to remember that there is a negative sign as well. So once you know the pH, using this formula, which we derived from the pH formula, you can calculate the hydronium ion concentration. Let's have a look at this example. What is the hydronium ion concentration in a solution that has a pH of 1.38? So we write the formula for pH, which is equal to minus log hydronium ion concentration. But because we are asked to calculate the hydronium ion concentration, we need to make this hydronium ion concentration the subject of this formula. So if we do that, we will get that hydronium ion concentration is equal to 10 to the power minus pH. So once we get this formula, we simply put in our value for pH that we are given, which is 1.38. And if we solve this, we will get 0.042 moles. So to get this value in your calculator, you press 10. then press S to power Y, then type minus 1.38, you will get 0.042, and the unit is moles. So it's either you put capital M like this, or you write it in full, 0.042 moles per liter. Now we learn how to calculate pOH. If you are asked to calculate the pOH of a solution, you use the formula pOH equals to minus log OH ion concentration. So you need to know the concentration of the OH ion in moles per liter before you can calculate pOH. Example, what is the pOH of a solution that has a hydroxide ion concentration of 3.41 times 10 to power minus 3 moles? So you write the formula pOH equal to minus log OH ion concentration. So you put in the value for OH ion concentration, which is 3.41 times 10 to power minus 3 moles. So you put it here. And when you get the minus log of this value, you will get the pOH to be equal to 2.47. So this is how to calculate pOH. For you to calculate it, you must know the concentration of the OH ion in moles per liter. Now we learn how to calculate OH ion concentration when we are given pOH. Let's have a look at this example. What is the hydroxide ion concentration in a solution that has a pOH of 2.47? So we write the formula for pOH, which is equal to minus log OH ion concentration. But because we are asked to calculate hydroxide ion concentration, we need to make the hydroxide ion concentration the subject of this formula. So if we do that, we get that hydroxide ion concentration is equal to 10 to power minus pOH. So if we put in the value for our pOH, which is 2.47 here, if we solve this, we will get that our OH ion concentration is equal to 0.0034 moles. So in your calculator, you press 10 for you to get this value, then press S, press to power Y, then type minus 2.47, you will get 0.0034. And then you put in your unit, capital M, which stands for moles, or you write it in full, moles per liter. Either way is correct. These are some practice questions that you can practice so as to familiarize yourself on how to do pH calculations. So these are the answers to the practice questions. You try to solve them first before you have a look to see whether you got the answers correct. So these are the answers. This is the answer to the third practice question. We now look at ionization constant for water, and it is given by K, capital K with subscript W. If we have 2 molecules of water, it gives hydronium ion plus OH ion. So the Kw, the ionization constant for this water, is equal to the concentration of hydronium ion multiplied by the concentration of the OH ion. So, and this is equal to 1.0 times 10 to the power minus 14 at 25 degrees centigrade. So this is just a constant. And minus log Kw is equal to pKw. So this means that pKw is equal to 14. And pKw is equal to pH plus BOH, which is equal to 14. So this is what ionization constant for water is all about. Right, so this is where I'm going to end for today's lecture. Please like this video and subscribe, and I will see you in the next lecture.